Hi, my name is Lilah. I'm a third-year PhD student in the School of Chemical Engineering at UNSW. My PhD project is supervised by Professor Cordelia Selomulya, Dr. Peter R. Wich, and Dr. Yang Wang. In my PhD project, I developed edible coatings based on polysaccharides with enhanced water resistance, with the main aim of preserving food. The challenges in my project is the edible coatings. So edible coatings are applied on food products, and the aim is to preserve the food and enhance the quality and prolong the shelf life. Finding the right balance between the components of the formulation to not only integrate into forming the network that is desired, but also to be a clean label, edible and natural components. That, along with finding the right adhesion, the right formulation to properly adhere to a specific food product. In addition to that, there's also the challenge of different temperature and storage conditions. For example, blueberries, from when they're being picked until they reach the consumer's house, the temperatures vary between room temperature to 2 degrees. And within this range, we need to make sure that the food coating adheres properly and doesn't form a sticky layer on top of the fruit, doesn't peel and doesn't crack. Generally speaking, coating formulation can be applied to the fruit in the field if we're looking to target fungi or reduce that kind of contamination. But another option is to apply the coating once they're being picked throughout the packaging process and the packaging line, which application methods can vary. It can be spraying, dipping, brushing, or etc. Typically, it would be adjusted according to the fruit and the packing house. Although edible films have been widely researched, I dive into specifically polysaccharides and I look into their major disadvantage, which still currently poses a great limitation as for their application. Polysaccharide-based films have high water vapor permeability, which limits their application throughout various storage conditions. And my formulation is a clean label. It's composed of components that are natural and components that are also extracted from food waste. So this is also a sustainable method to reutilize food waste products. The outcomes that I was aiming for are to develop a polysaccharide-based coating layer with enhanced water barrier and compatibility with blueberries as a proof of concept, to overcome the current limitation of this biopolymer, its high water vapor permeability, which limits its application, by allowing further applications, and to reduce food loss by preserving the fruit.
We are very excited about this project. We have shown that the shelf life for the blueberries can be extended, and we also can use something that is natural and edible. We have been able to file a provisional patent for this particular formulation, and currently we are looking for interested partners who wants to partner with us and collaborate with us to take this technology further for commercial purposes.
There's economical benefits for growers, for retailers, for consumers. Given the components that our films are composed of, it's also sustainable in the sense of recycling and reutilizing, repurposing food waste. My goals to the future are to advance this technology and bridge the gap between the laboratory novelties and the industrial application. So to bring this technology to be applied throughout the distribution chain and allow preservation of food.